Hello students, today we're going to be talking about parallel and perpendicular equations. We're in the third unit on the fourth lesson, talking specifically about the equations of these lines, and it's sort of a reminder or a refresher on the stuff that you learned in algebra, talking about slopes and y-intercepts. Sort of gave away the do-now there, but let's just breeze right past that and talk about the learning target. We're going to be able to identify and differentiate between parallel and perpendicular lines by analyzing their individual slopes. Identifying means looking at an equation and trying to determine its slope. And then differentiating means saying, well, there's a difference between this slope and that slope, or there's a difference between this pair of slopes and that pair of slopes. We're going to be talking specifically about parallel and perpendicular lines. As you know, parallel lines are lines that intersect at 0 points, right? They never intersect. Perpendicular lines, they do intersect and form a right angle. And by analyzing their individual slopes, so you definitely do have to remember how to find the slope between 2 points, and finding the slope from a linear equation is also important. Let's take a look at the do now, pause the video, try this out, and then come back to see if you got it right. Alright, like I said previously, the slope and the y-intercept are the two things we need to write a linear equation. You may remember, or you probably should remember, that y equals mx plus b is the slope-intercept form of a linear equation. That's what we call it, slope-intercept, because the slope is m and the y-intercept is b. That's what it says here. The equation of a line is going to look like that. It's going to have that y equals mx plus b, and the only thing that we're given are these 2 points. Keep in mind from the previous examples that we've done in chapters that have gone by, we identified the points as x1, y1, and x2, y2, because this is the first point they gave us and the second point they gave us respectively. First, we find the slope. Easy enough to do. Then we find the y-intercept. The procedure is very simple. We write down y equals mx plus b. We take our slope, which was, in this case, -3, and we are taking that information and substituting it into the equation for m, because the slope is m. The other two pieces of information that we're going to substitute in are x and y. And I chose to substitute in x1 and y1, but I could have easily substituted in x2 and y2. I would have gotten the same result. So substituting all those values in gives us one unknown. The b is the unknown variable here. So we solve for b, and that turns out to be 10. So now I have 10 equals b, or b equals 10, and m is equal to -3. Since I have the two things I need to write a linear equation, I'm just going to write it. Y equals mx plus b, y equals -3x plus 10. So now let's move on to the notes section. We're talking about parallel lines first, because parallel lines are one of the main focuses of this lesson. They're lines on the same plane that are the same distance apart and do not intersect. And we also know that they have different y-intercepts. Let's fill those in. One other piece of information that you should know is that you can see these two parallel lines that are running alongside of each other. As it says here, same distance apart, they never intersect. They have different y-intercepts. This one's up here, this one's down here. And they have the same slope, which means they're tilted in exactly the same way. Their rise over run is the same. So I could identify their slopes very easily just by counting out boxes, right? For example, if I counted out these boxes, it's down 2 over 1. Similarly, down 2 over 1, it's the same exact slope. Lovely. Another way that you can see it, not just graphically, is by looking at the equation. If I'm looking at this equation, y equals 2x plus 4, and y equals 2x minus 1, the second equation, I can see that both of these have the same exact slope. It's also true that they have different y-intercepts. Slope is 2 for both of them. The y-intercept here is +4, which means it would intersect the y-axis up here. And the y-intercept for this line is -1, which means it's going to intersect the y-axis down here. They have the same slope and different y-intercepts, therefore they are parallel. The only time that this might be a confusing question is if the two lines have the same slope, but they don't have different y-intercepts. Here's an example. Now, when I'm looking at this equation, it says 6 divided by 3 for the slope. I can tell that 6 divided by 3 is equal to 2. And at first glance, that 2 slope means it should be parallel to this equation because I have a 2 slope over here. However, looking at the y-intercepts, this y-intercept is -1. And if I were to solve this equation for y, in other words, get y by itself, I would subtract 5 from both sides, and I would get a -1 for this slope, same as the slope over here. These two lines, the lines that are represented by these two equations, are not parallel. That's something to keep in mind. Sometimes algebra teachers and geometry teachers will give you a little curveball and say, are these two lines parallel? And they will have the same slopes, but they'll also have the same y-intercept, so be careful with that. In the first model problem, it asks us to write an equation for the line that passes through negative 3, 5, and it's parallel to the graph of y equals 2x minus 4. You should remember from the do now that you were supposed to take the x and the y and use that slope formula to find the slope. In this case, it's a little bit easier because they give us a slope to base it on. Step 1 says to identify the parallel slope. Easy to do because the slope here is 2. And I'm told that the lines are going to be parallel, so the slopes are going to be equivalent. And that was easy enough. Now what we're asked to do is to label the x and y values. Well, some information is given to me here. The x and y values are here. The negative 3 and 5 are x and y, so I can label them fairly easily. And you might ask yourself, well, why am I not labeling this as x1 and this as y1? Because in this case, I only have 1 point. I don't have to differentiate it between x2 and y2 because there's only 1 point here. Step 3 is to plug in the slope, the x and the y, into y equals mx plus b to find the y-intercept b. Remember, plug in means to substitute, and then find that y-intercept because it's going to be the only unknown value. And you can see here I substituted those values into the y equals mx plus b equation, and I got b is equal to 11. So now I have all the information I need. I have the piece of information that the slope is equal to 2, and I have the information that the y-intercept is equal to 11. So all I have to do is write the new equation with the parallel slope, which is this, and the new y-intercept, which is the one I found here. Now some students sometimes ask, well, why didn't I use negative 4? Keep in mind from the previous parallel lines example here that these two lines are not parallel because they have the same y-intercept. You can have two lines with the same y-intercept be parallel. Now those are just the same exact line. So there we go. We have answered the question. It asks us to write an equation for the line that passes through the point negative 3, 5 and is parallel to 2x minus 4, and that's the equation of the line, 2x plus 11. Do a real quick check here. The 2 is the same exact slope. The 11 and the negative 4 are different y-intercepts, so that checks out. And we should be able to check to see whether negative 3, 5 works for this equation by substituting it in and seeing if it is the equation is equivalent. All right, in the check here, we were able to take our equation, y equals 2x plus 11, substitute the two values, the 5 and the negative 3 for y and x respectively, into the equation, and we got a result of 5 equals 5. What this means is that this point does in fact lie on this line. In other words, this line is a bunch of points, a set of points, and negative 3, 5 is one of those points. Great. Moving along to the model problem number 2. This question asks us if the following two lines are parallel. We can't identify one of their slopes here, this 2x plus 3y is equal to 9, because, well, simply it's not in the correct format. So what we have to do is take this equation and solve it for y. All right, one thing that I wanted you to know is that this equation is written in so-called standard form. What we want to do when we're trying to identify the slope of a line is turn that standard form into so-called slope-intercept form, which you can tell because it says y equals some number times x plus or minus some number. Anyway, we have to solve this by getting y by itself. Subtracting 2x from both sides gives us the y term all by itself on the left-hand side, and then dividing every term by 3 gives us y equals negative 2/3 x plus 3. Here we have the slope of the line, which is negative 2/3, and here we have the y-intercept of the line, which is a positive 3. That tells us that the line is going to intersect the y-axis at 3, and the rise over run is going to be negative 2 rise, which means it goes downwards by 2 boxes and over by 3 boxes, or 3 units. This slope doesn't have a number listed, but we know, of course, that that means the slope is 1. So I have a line with the slope of 1 and a line with the slope of negative 2/3. Turns out that these lines are not parallel because they do not have equal slopes. Easy peasy. Skipping the check for understanding because you're going to be doing that in class, let's talk now about perpendicular lines, which are kind of like parallel lines, but actually exactly opposite. There are a lot of things that you might know about perpendicular lines, but one of the big things is that they intersect at right angles. When these two lines intersect, which is different than parallel lines, right? Because parallel lines don't intersect. When these two lines intersect, they form a right angle at their intersection. As a matter of fact, they form 4 right angles. One other thing that you should know is that perpendicular lines have slopes that are negative reciprocals. If you didn't know what a negative reciprocal was, well, don't worry because I'm about to tell you. These words mean things. In other words, negative means opposite signs. The two slopes are going to have different signs. If one of them is positive, the other will be negative and vice versa. And then reciprocal, like reciprocate, means to flip upside down, to flip the fraction. So if the numerator and the denominator are 1 and 2 respectively, the numerator and denominator of the new fraction of the reciprocal will be 2 and 1. In this example, I have a slope which is 2. It's easy to find out because this is in slope-intercept form. And in this case, in this equation, I have -1/2 as my slope. These lines have slopes that are negative reciprocals. Don't believe me? Here, I'll show you. This slope, which is 2, can be represented as a fraction, which is 2 over 1. Similarly, this slope, which is -1/2, can be represented as a fraction, which is -1 over 2. Notice what happened was, we have different signs, this one's positive and this one's negative, and they're reciprocals. This is 2 divided by 1, this is 1 divided by 2. Since they are negative reciprocals, that means that these two lines are perpendicular. It's an easy way to check to see if two lines are perpendicular without having to graph the actual lines on a coordinate grid. In the model problem, it asks for an equation of a line that passes through this point and is perpendicular to the graph of this line. So it seems like there's a little bit of work to do here, but let's get started. The step 1 is to rearrange the equation to y equals mx plus b into that slope-intercept form to clearly state that slope. We just need to figure out what the slope is here. All right, so far so good. We found that the equation is y equals -2/3 x plus 4. That means that our slope for this line is -2/3. Remember, we're trying to figure out the slope of the perpendicular line though. So what we have to do now is take this equation, or rather just take this slope, and turn it into its negative reciprocal. So here we have the slope, which started out as -2/3. In order to turn it to its negative reciprocal, we change the sign from negative to positive, and we flip it upside down. So now we're looking at a slope of +3/2. Why were we supposed to do that here and not on the previous problem? Keep in mind, this word perpendicular indicates to us that we need negative reciprocal slopes. Next, we need to label the x and y values, and in this case, we only have one point to use. We have an x value here of -4, and we have a y value here of 6. Seems like a pretty straightforward step. Step 4 is to plug in the perpendicular slope, which we found here, and also plug in or substitute x and y, which we found here, into y equals mx plus b in order to find the y-intercept of the other equation. Keep in mind, we already have the slope of the other equation, but we don't have the y-intercept yet. Here are all my substitutions. Oh wait, my colors are wrong. Phew, that makes more sense. All right, 6 is equal to 3/2 times -4 plus b. Keep in mind that this is a fraction, 3 over 2. I wrote it out horizontally here because it's just easier to write out in text, but it's the same as 3 divided by 2. I know that 3 over 2 times -4 is -6. Adding that 6 to both sides gives us 12. So now I have two pieces of information that I need. I have my y-intercept, which is 12, and I have my slope, which is 3 over 2. Now my last step is to write the new equation with the perpendicular slope, which is this, and the new y-intercept, which is this. All right, just checking to see if we did this right. We're supposed to write an equation for the line that passes through this point and is perpendicular to this line. That's what we did here. This line is going to be perpendicular to the given line, and it also passes through that point. The model problem should be fairly straightforward. Here's the slope of one line, and here's the slope of another line. If we know that those two slopes are perpendicular, we need to determine and state the value of x. Since they're perpendicular, we know they have negative reciprocal slopes. Here's how I'm going to approach this. I know the slope of ST is 8 over 3. But I do know that QR and ST are perpendicular. They have negative reciprocal slopes. So the first thing I'm going to do is turn this slope into its negative reciprocal, which should actually be -3 divided by 8. My next step now is to say, well, I know that this is my negative reciprocal slope, which means it should be equal to this slope. So this number should be equal to this number. Seems like we have a proportion on our hands. And here's that proportion all written out. -3 over 8 is equal to x minus 1 over 4. Now what we have to do in order to solve this proportion is cross multiply. That's right, crisscross applesauce. This times this, and this times this. An algebra problem. All right, once we cross multiply, we get 8 times x minus 1, which is here, -3 times 4, which is -12. Distributive property here, add 8 to both sides here, and solve for x. And remember, we were asked to determine and state the value of x. That's all that we would have to do. I'm going to leave the check for understanding to class, which means we have come to the end of the video. In this video, we talked about parallel and perpendicular equations, specifically about finding parallel and perpendicular equations by analyzing the equations of given lines, especially looking at their slopes and y-intercepts. All right, folks, good luck studying.